Hello, this is Ms. DB. In this lesson, we are going to begin Chapter 12 on transformations, and today we'll be talking about Section 1 on reflections. Our objective is to identify and draw reflections. Isometry is a vocabulary word. We did cover this earlier in the year, but we're going to review some of the things that we learned way back in Quarter 1. An isometry is a transformation that does not change the shape or size of a figure. Reflections, translations, and rotations are all called isometries. They're also sometimes called congruence transformations or rigid motions. We'll be learning about each of those in this chapter. So reflection is the first one we're going to talk about. That is a transformation that moves a figure. The original is called the pre-image, by flipping it across a line. The reflected figure, the new one, is called the image. A reflection is always an isometry, so the image is always congruent to the pre-image. So the first part that you're going to be working on for your worksheet is just saying whether or not it looks like a reflection. So in A, in order to be a reflection, you have to have flipped the pre-image, which I believe is the blue one, over a line to get to the red one. If that didn't happen, then you would just say no. It also says to explain. So this one says no, the image does not appear to be flipped. B, though, does look like if you drew a line. Let me try to draw a line, even though I don't have a straight line tool, so it's a little tricky. But if I drew a straight up and down line about here, pretend that's straight, then this would be, you could see that that would be a reflection about that line. And in the week, what are we on, 14 folder, I did put the videos that I made for Lesson 1.7 and even the completed assignment from Lesson 1.7, so you could go back and review basic transformations, of which reflections are one of them. So these are just some more examples. You can say whether or not you believe these are reflections. A is not, and the reason it's not is because, see, this is the little point here, and the little point over here is like over here. It looks like maybe it's been rotated. And in B, I would say yes, it looks like it's been reflected about a line. There is directions on how to draw reflections, even though they're kind of tricky to do in the online world. So what you would do is draw a segment from each vertex of the pre-image to the corresponding vertex of the image, and then your line of reflection should be the perpendicular bisector of every segment connecting a point in its image. A reflection is a transformation across a line, and the line is called the line of reflection. And as you can see, that would be the perpendicular bisector that would connect the pre-image A and its image A prime. So this one says to copy the triangle and the line of reflection. You would not have to copy them because you're not working out of a textbook. You're working with a worksheet. And then draw the line of, or draw the reflection of the triangle across the line. So what you would do is you would make perpendicular line from here to here, and this should be congruent to this. And then you'd put your new point here. And you do the same thing for this point. You would use a ruler, and this has to be the same length as, I guess it would be about here. And then for this one, and all of these lines would be perpendicular, 90 degrees, so you could use a protractor to make sure. And then your new points would get connected, and that would be a sketch of the image. Now theirs is going to be a little more perfectly drawn. Oh, I see my perpendicular lines were off. And then they would draw the points the same equidistant from the line of reflection, and then they would connect them. What we'll be doing is the part with the coordinate plane, because it's easier then to create our reflections. You can also do these in Sketchpad. Sketchpad has tools for transformations, including reflections, where you set the line of reflection, and then you select all the points of the pre-image and the lines, and then you go to the Construct menu or the Transform menu and pick reflection. This one is an interesting application. It says two buildings are at A and B. They're to be connected to the same point on the water line. Where should they connect so that they'll use the least amount of pipe? So it's asking you to pick a point on this line. Should it be here? 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 Where should the point be so that if we make line this plus this, we're using the least amount of pipe? The answer is that if we reflected it, so if we reflect B over the water line, then these two lines are congruent. And AX plus AB is the same as AX plus XB prime. And it's the least when these would be collinear. So if I reflected either B or A across the line, then I could line them up so that they're in a nice line. So the answer is, well, you'd pick X, so that if you connect B prime and A, it makes a straight line. Then X would be that intersection of our line of reflection, the water line, and the line that we made from B prime to A. It's kind of interesting. And then this is just to make sure that you have the right answer. All right, so if we are asked to reflect in the coordinate plane, which is the other thing that you'll be doing on your worksheet, is this is what you're going to do. If you're reflecting across the x-axis, all that changes is the coordinate of y will change to the opposite sign. So if it was negative, it changes to positive. If it was positive, it'll change to negative. The x-coordinate stays the same. If you're reflecting across the y-axis, the x-coordinate is the opposite. So if it was positive, it changes to negative. If it was negative, it would change to positive. The y-coordinate stays the same. If you're reflecting across the line y equals x, which is the diagonal line that cuts your coordinate plane in half diagonally, then your x-coordinate goes to the y-coordinate and your y-coordinate goes to the x-coordinate. So you flip-flop. So if you had a point 2, 3, it becomes 3, 2. If you had a point 1, 1, it'll stay 1, 1. If you had a point, because that's already on the line, if you had a point 4, 2, it will change to 2, 4. So all the coordinates would change. Flip-flop. All right, let's see. First, you have to know what line do they want you to flip it across. They want us to change it by going across the x-axis. It might help to highlight your x-axis since it's kind of hidden in our coordinate system. There's our x-axis. Okay? We want to reflect this triangle over that line. Every coordinate will change by changing, do you remember? Across the x-axis, the y-coordinates will switch to the opposite sign. The x-coordinates will stay the same. The y-coordinates will change by changing their sign to the opposite. Remember, we put an apostrophe after it. That's called x prime to show the image, the new figure. The x-coordinates stay the same. The y-coordinates change to the opposite. So we just have to plot these new points. So 2, 1, and you can do this in Sketchpad or Desmos if you want. Actually, Sketchpad would be better. Or you can use the tools in Word and just draw the lines. You don't necessarily have to put the points. And negative 4, 3, 1, 2, 3. And z is 3, z prime is 3, negative 2. So this is x prime, y prime. You don't have to label on the homework. 3, negative 2. You can also do this by looking. You know, this one's 2 up from the x-axis, this one's going to be 2 down. This one's 1 down, this one's going to be 1 up. So your resulting figure, you'll connect your points now, is going to kind of overlap your original. And it will look like that. So they often will be on top of each other, and that's just fine. Did they graph theirs? Yeah, mine's just a little bit on top of it. There's their pretty one. This one says to reflect about the line y equals x. Now that line is the line that goes through 0, 0, 1, 1, 2, 2, and so on. It's that nice diagonal line that cuts your coordinate system in half that way. Now every one of these points are going to switch their coordinates. S prime would be 0, 5, T prime would be -1, 3. So we graph these. 2, -2 would be right here, and 0, 5 would be right here, and -1, 3 would be right here. And then we will connect those points to make our reflected triangle over the line y equals x. Okay, one more. This is across the x-axis again, which means all we're going to change is the y-coordinates. So we change each one's y-coordinate to the opposite sign and plot them on the coordinate system. And then connect them with lines, and you have your image in red. It is nice to use different colors if that's an option for you. All right, that's it. So practice and let me know if you have any questions. And next we'll work on translations. Thank you very much.